Okay, so that's video number 5. We are still on logarithm, differentiation of logarithm. Okay, so last time I asked you to have a little bit review of what we've done and try this example 5. If you've done it, you've tracked your answers from the PowerPoints and you are all good, then you can skip the first possibly 5 to 10 minutes of this video. Okay, so I'm going to try to um, do my solutions right here so you can have a look if you can't get your solutions. All right, so for the first one, this is y equals to 2 times log x plus x squared. So actually you see that two parts. So it's like addition of two different part functions. Okay, so and this is more about the y coordinates and the gradient of tangent to the curve at that point corresponding to the given x. So you need to find the y coordinates and the gradient of tangent to the curve. Okay, so that two things. Gradient of the tangent. Okay, so how can you get the y coordinates? Okay, to get the y coordinates, all you need to do is just put x equals 1 into the equation. So log 1, if you still remember, that's 0. 2 times 0 plus 1, so it's just 1. Okay, and second part is the gradient of tangent. So how can we find the gradient of tangent? We've learned that before. All you need to do is do the differentiation, and the derivative is the gradient of tangent. Okay, so you have to do the derivative first, dy over dx. And okay, let's write in operator. Okay, so m plus dx squared. Okay, and that's 2 times 1 over x plus 2x. And so a better way to write this is like that. Okay, that's the gradient of the tangent at point x, but it's not specified enough because we've given x is 1. So to find the gradient, you need to do the substitution. So that's the symbol I like. I write x equals 1 into the derivative. So that's 4. Okay, so that's basically, that means gradient at the point 1, 1 is 4. Okay, that's for A. Let's do that's for part B. Okay, so first, y coordinates. You put x equals 4. So that's logarithm 5. Okay, so logarithm 5 is not a number that you can get without calculator. So if that's paper 1, you just leave your answer like logarithm 5. That's good. That's good enough. Okay, to find the gradient, you need to do the differentiation, right? Differentiation of such a function, you see. Okay, we just try to do a little bit revision. Oh, okay, so not right now. I'm going to write that operator. So you see that 2x minus 3 and the variable part just x. You can't do the differentiation straight. So that means you need to create. So that's 1 over 2x minus 3. And okay, for the second part of it, okay, you can do things like this. And so it will become 2. Okay, that's 0. Okay, so this part is 0. Okay, so that's 1. This is 1. So 2 times 1 minus 0 is 2, right? That's it. And you have to do the substitution. And the substitution is x equals 4. Okay, so that's 2 over 5. That's it. No problem at all for this part. Okay, and okay, so some of the homework here, I will come back and give you the homework. Okay, then we try to apply the Porter rule and also the quotient rule for all the logarithm function. Okay, and example 6 is more about the Porter rule, and example 7 is more about the quotient rule. If you still struggle with the Porter rule and quotient rule, you really need to go back to have some of the revisions of the Porter rules and quotient rule examples we did. Okay, so I hope you have been already okay with Porter rules and the quotient rule, right? So can you see that this is a Porter rule? You can see that that's x times log x. So actually, that's 2 parts in the function. Okay, so let's say if I say u is x and v is log x. Okay, and what will you get? You can say, okay, du over dx is 1 and dv over dx is just 1 over x. Okay, and if I try to differentiate the whole function fx, I'm going to differentiate x times log x, which is u times v, because u is x, v is not x. Is that okay? Still remember the Porter rule? Can you write the Porter rule right here? What would be the Porter rule? Okay, give you 10 seconds. Okay, 5, 4, 3, 2, 1. Okay, so here's the Porter rule. Right, so u is just x and v and that's dv over dx. That's 1 over x plus v is log x. Be careful about the substitution. U, this is du over dx, which is 1. Okay, so that means you have x times 1 over x, which is 1 plus log x. That's it. Okay. For part B, it's a little bit tricky. Can you see any products? Can you see any products here? That means, can you see like fx equals u times v over here? Thing is not that obvious. It's okay. It's not very easy to see. Okay, you need some law for logarithm if you still remember. Okay, and I will give you some hints. I'll give you some hints. If you still remember, that's a one law of logarithm, saying like if you have any logarithm m to the power of n, okay, how can you simplify that? We write that into 2 parts. Okay, I'll give you some time on it, okay, and you try to see if you could search for that, search your memory. If you can't search anything in your memory, you might just go back to the PowerPoints in our previous section on logarithm. Okay, and that's such a rule. Okay, I'll give you like 1 minute for the search. 1 minute for the search. Okay, good. Okay, so have you got it? Okay, so let me show you where you could look for it. So when you go to OneNote, so you see the different pages for teaching materials. So that's a logarithm there. So that's the first time when you go to exponential and logarithm, you can't see the law for logarithm right here. That's in Unit 2. But when you come to Unit 3, that's we learned that's in term 4, okay, of last year. Okay, so you see the laws of logarithm. So if you click that, okay, so see the variety of functions. So that's a log. That's a law number 3. Let me copy it and to show you how it works. Okay, so that's the logarithm of a power. So if you have any logarithm, you have m to power p, you can always bring that p to the front if you still remember that. And okay, so that means right here I'm using n, but it's still the same. Okay, so you can bring that n to the front and it becomes logarithm m. Okay, so that's search completed. Okay, so that means I can rewrite that fx into 3x. I bring that 3x to the front using that law for the logarithm. Okay, so right now you have the multiplication between two parts, and your u will be 3x, your v will be 2, log 2x plus 1. Yeah. Okay, and obviously, if you try to do your differentiation of u, and that's 3, and your differentiation of v. Okay, so when you differentiate that 2x plus 1, you know you have to use chain rule, right? To use chain rule, okay, in this case, you just create that 2x plus 1 here, and 2x plus 1 there. And so that becomes 1 over 2x plus 1, and the second part is just 2. Okay, so it's 2 over 2x plus 1. Sorry about the space. Okay, okay, I possibly used too much room there. Okay, I might just write my answer over there. Okay, so that means right now, if I'm going to do the derivative, I'm going to do the u times du times v, and that's u dv over dx plus v du times du over dx. Okay, my u is 3x. My dv over dx is 2 over 2x plus 1. So it's 2 over 2x plus 1. My v is log 2x plus 1. But my u is a du over dx is just 3. Okay, so that means I'm going to have 6x over 2x plus 1 plus 3 times log 2x plus 1. But it's much better to bring that 3 to the front to multiply logarithm. Okay, so that's how it is. Then you can get your answer over here. Yeah, and let me check my solution. Not here. Oh, where is it? Differentiation. Okay. That's logarithm. Yeah, so that's how it is. All good, and we're going to move on. So here are quotient rules. Quotient rules, okay. And quotient rule, you must have like a fraction. You have u above or v below, okay. So that would be a u, and that would be a v. Okay, so let's say u is log x, v is x plus 1. So you differentiate u, then you have 1 over x, you differentiate your v, so dx over x is 1 and d1 is 0. Yep, so it's quite easy, right? And okay, so So the whole thing about differentiation of fx is to differentiate u over v. Okay, what would be the quotient rule? Okay, again, 10 seconds for you to write your own quotient rule right here. Okay, 5, 4, 3, 2, 1. Oh, good. V square. And remember, you always need to differentiate that u first, and then take away, you swap that row. Okay, so v square is just x plus 1 square. Your v is x plus 1, and your du over dx is just 1 over x, minus u, which is log x. Okay, I better put a bracket here. dv dx is just times 1. Okay, and so the final answer is just x plus 1 over x minus log x. Okay, that's not going to be very nice in terms of the expression. You can simplify it further. Okay, so one way you can simplify it is just try to do that x plus 1 over x. Yeah, x plus 1 over x, you try to split up like x over x plus 1 over x, so it becomes a 1 over 1 plus 1 over x. Okay. That's a bit better. Okay. Good. And all right, so for the next one, so pretty much you can see a quotient right here, so you can use quotient rule, right? Okay, try to get your u and try to get your v and try to get your du over dx and try to get your dv over dx over here. Then apply the rule. Okay, I'm going to give you 4 minutes on this one. So pause your video, spend 4 minutes at least. Try to get your answer, okay? Okay, I hope you've taken your time, okay? And so what I'm going to get is to change your color a little bit. And that's 3x squared, and that's v is log x, okay? du d3x squared should be 3 times 2 times x, right? So it should be 6x. And dv, which is quite obvious. So 1 over x, you have 6x here. All right, so let's see. And you will have v times du over dx minus u times dv dx. Okay, don't mix up the order. You must go with d over dx first. V squared. And that v squared is log x. Remember, you need to have a bracket here. If you don't have a bracket, what's the problem? Okay, the problem is if you write things like this, normally people would think that square belongs to x rather than the whole log x. So that's why this is not the same as log x squared. Okay, right? So for log x bracket square, that means square belongs to the whole log x, and for without bracket, that square belongs to x only. Okay, so you need to be careful about this. All right, so that bracket is necessary, and you have v, which is log x, and then you times d over dx, that's 3x squared. And, oh, sorry, it's difficult. D over dx is 6x, and you have u, use 3x squared, and dv over dx 1 over x. Okay, and you can do some simplifications. And that 6, you move to the front of log x, which is a proper way to write those things. 3x squared times 1 over x, so you cancel 1x, there's still 1 left. So that's minus 3x. Okay, let's check with the answer in the, yeah, they look good. Oh, good. So that's it. Then we can say we know how to apply the logarithm in the Porter rule and um, quotient rule of differentiations. Okay. All good. So, and I'm going to give you some homework, if you don't mind. So last time I gave you 9 questions, so that's amount for 1.5 hours. Okay, so this time I'm about to do the same. So it's recommended homework. So you want to do more, that's always welcome. If you can't do them more, then as long as you feel you are all right with the fluency, then that's okay with me. But I guess one hour is at least for each of such sections. Okay. So find the derivative. So that's, I think you need to ramp up with your fluency. And I would like you to do some of those questions. 1, 2, and possibly, oh, these 2 are interesting. You see the difference between 2a and 2b, if you can. Okay. And the y coordinates and the gradient. It's necessary to do one of them, I guess. Let's try this one. So that's 5 questions. I think that's good enough for this part. You can always do more if you want. And the Porter rule and quotient rule, and I would like you to try more of it. This one and so there are 4 over here and there are 5 over here. So in average, might possibly you say. So I think some of the questions are really easy, and possibly let's say 10 minutes for each one. So so there are 9. So 90 minutes, 1.5 hour at most. I guess some of you might just finish this within 45 minutes. So let's be conservative, 1.5 hours. So that 3 hours work, and if you if you don't need to spend a lot of time recalling the facts, possibly within 1.5 hour or half of the time you need to spend. Okay. Anyway, so spend the time and okay. And so you can bring the homework to me when we meet after the online schooling. Okay, so there will be some time we meet, or if that's delayed too long, you can send the photos to the folders in your OneNote. Okay, that's all good. And okay, so thanks for watching. Okay, any question, please you can ask me in the YouTube, and you can send me the questions in email. I would like you to do that in YouTube because then others can see, and I know you actually there's someone's watching my YouTube. Okay, so not many watchers, I think. Anyway, okay, so see you next time.